my screen is visible to you. So that was Gini index, and when we use it, our decision tree algorithm will be known as CART. And I have just discussed the formula for calculating the Gini index. Okay, the attribute provides the smallest Gini split D or the largest reduction in impurity is chosen to split the nodes. Means to say that whenever we find the Gini index is small for a particular node, we will select that node for the splitting purpose. Okay, so need to enumerate all the possible splitting points for each attribute. So from the previous example, again you can apply that the same thing, this Gini index, and you go for calculating what the means Gini income or low medium, and then whenever you find a smallest value, then you will select that node for splitting. Right, suppose here we got 0.4.59 and then 0.440. Then what would be that note that you select for the splitting is this one where you got the value 0.440. Right, so you see that we have these three measures: information gain ratio, and Gini index. Some advantages are there with respect to each such measure. Also, some disadvantages are there with respect to such means selection matrix. Like information gain, this is biased towards multi-valued attributes. Then gain ratio, it tends to prefer unbalanced splits in which one partition is much smaller than the others. Then in Gini index, it is again biased to the multi-valued attribute and has difficulty when number of classes is large, and tends to favor tests that result in equal size partitions and purity in both partitions. So these are the some you can say disadvantage with respect to this one. But maximum time we use this information gain. Okay, these are some other attribute selection measures. You don't need to worry about them. But information gain ratio, and gain index, these three are very important. Now, one problem that we face in case of distant is overfitting problem. And what is this? An industry may overfit the training data. This means overfitting means what? Too many branches, and some may reflect anomalies due to noise or outliers. So this will imply what? Poor accuracy for some unseen samples. And if such situation occurs, we go for pruning. Okay, and there are actually two approaches for that. First one is pre-pruning or post-pruning. Okay, these two are the approaches for to avoid this type of overfitting problem. And what is pre-pruning? Halt tree constructions early. Do not split a node if this would result in a goodness measure falling below a threshold. Means you will first select a threshold value, and if you see in advance that that goodness measure is falling below that threshold value, then you don't go for splitting that node. Okay, so this is a pre-pruning approach, but the only problem is that it is very difficult to shows that threshold value. Okay, then we have post pruning. Now, from the name itself, it is very clear that you are going to apply this pruning after the tree construction. So here you will remove branches from a fully grown tree, get a sequence of progressively pruned trees, and use a set of data different from the training data to decide that which one will be our best pruned tree. So pre-pruning and post-pruning. Now, a simple question to you. According to you, which one, this pre-pruning or post-pruning, will be means will involve actually less complexity, or what you will prefer, pre-pruning or post-pruning? Now, some enhancement to the basic decision tree inductions. We have, like, we allow for some continuous values attributes to dynamically define that new discrete valued attributes that partition the continuous attribute value into a discrete set of intervals. Then we handle some missing attribute values, then attribute constructions. This means what? We go for creating some new attribute based on existing one that are sparsely represented, and what we get in return, that it will reduce the fragmentation, repetition, and replication problem. Right. Now, for a large database, when you go for applying this, then this may not going to give you an accurate result. In such cases, when we have a very large database, we have another option that is known as random forest. Okay. So what is random forest, how it works, we'll discuss in next lecture. Okay, that's all for today. Thank you.